Our calculator is limited in what it is able to do for graphing non-functions. And obviously circles fall into the category of non-functions. So what can we do to rewrite the equation of a circle so that we can actually use our calculator to graph? One of the unfortunate realities of the graphing calculator is that it's limited in what it can show us. But if we're careful with our algebra, we can see the different parts of the circle, not as an entire circle, but instead as two half functions, or excuse me, two half circles that are their own functions. So in order to do that, we need to begin by taking our circle and solving for y. So we're going to start by subtracting x squared from both sides. And then we'll finish by taking the square root. When we take the square root, that gives us our positive and negative root of 16 minus x squared. We now have two functions that can be graphed as representations of the two halves of the circle. So let's start with the square root of 16 minus x squared. And underneath that, let's graph the opposite of that exact same expression, 16 minus x squared. And what we should expect to see with the graphing is the two half circles that would form this entire circle. So we graph, and there's our two half circles. Now you'll notice that on the right-hand side, if you zoomed in a little bit, you'll see that they don't actually connect. That is also one of the limitations of the calculator. You'll also notice that this graph looks a little elliptical in that it looks a little bit stretched out from left to right. That's because of the window that we're trying to graph it in. Look at how the x-axis and the y-axis are scaled. There's a lot more space between each unit on the x-axis than there is on the y-axis. If you want to see it in a square view, you can press zoom and then number 5, which is square, and you get a more circular look from the graph. But we have these two individual pieces that form together to form the exact same circle we would have got from the equation over here. Just needed to graph them in two separate pieces. Independently, they're both functions. These are radical functions. Independently, they're both functions. But put them together, and they give us that circle look that we're hoping for. Similarly to that example, let's look at an example of a circle that's not centered at the origin. Instead of being centered at the origin, this circle is centered at the point 2, -1. It has a radius of 3 thanks to this 9 over here. So we know that our r is going to be 3. And we're going to solve this using the square root method. So normal thinking would be, when I solve with the square root method, I push the constant term over to the right, and then I try to get to a point where I can take a square root. The unfortunate part of that is I definitely don't want to multiply this out. Because if I was to multiply that out, it would create y squared plus 2y plus 1, and then I would have two y's that I would have to worry about in trying to solve for. We're actually going to go a little bit of a different route. We're going to begin by taking off of both sides this entire multiplication x minus 2 squared. That will eliminate it off of the left and leave us on the left with just y plus 1 squared is equal to 9 minus x minus 2 squared. And again, for the purposes of this exercise, I am not worried about multiplying all of this out. That is not my principal concern. But that does leave me with this square root by itself. So if I then follow that up with a square root of both sides, I'm left with y plus 1 is equal to plus minus the square root of 9 minus x minus 2 squared. And if my goal is to get it where it's y equals and I can actually type it in the calculator, then my last step is to just subtract 1 from both sides. So I have plus minus x minus, or excuse me, 9 minus x minus 2 squared, and then minus 1. And you can already see how this is going to be similar to what we just did with the circle above in the previous example. It has a similar look on the inside. There's that r squared that we needed from the creation, the original circle. We had the same thing in the last example with the 16. Here's the minus 2, which is still going to shift me to the right, and there's the minus 1 that's going to shift me down. Now that that minus 1 is outside of that square with the y, it now operates as we would expect, where if it's a minus 1, it'll move it down. And then we have our plus minus for the 2 halves of the circle. So let's graph both of these and test to make sure that we have the function, the 2 half circle functions that we're looking for. So graphing this very carefully, 9 minus, this is where the parentheses comes in to help, x minus 2, all of that squared. That's the whole interior of the radical. Then I want to make sure I move outside the radical for the minus 1. And then we'll do the same thing again, just the opposite of that expression. Make sure I close off my parentheses, make sure I get my minus 1 outside. So again, we're going to be looking for this image right here. We're going to be looking for this circle that has a radius of 3 and is centered at the point 2, negative 1. And we can see we're over at 2, negative 1. We could zoom in a little bit. A zoom box might be helpful, where we could set up a box that goes around the outside of the circle. Whoops. Excuse my error there. Let's try that again, zoom box. Remember, zoom box is you set a corner, and then you set the corner that is diagonal from it, so you can see the whole thing. And there's my circle. And again, there's that limitation that we have on the edges where we're not able to see the connection of the 2 halves of the circle. And that has to do with the domains of the functions and all of that, and what the calculator thinks it's allowed to do and not allowed to do at those endpoints. So we know that this is the representation of the circle. Here's 2, negative 1, which is roughly right in the middle. Or I shouldn't even say roughly right in the middle. It's absolutely in the middle of those 2 pieces. So you can graph a circle on your calculator. You just can't graph it in the same way that you can graph it with a more dynamic graphing technology like a Desmos or an online graphing calculator. You just have to treat it as two half circle functions as opposed to looking at the entire circle at once.